Alrighty, we are supposed to find the limit as h approaches 0 of f of x plus h minus f of x over h. That is known as the slope of tangent lines. It's the limit as h approaches 0 of the difference quotient, the one and only difference quotient. So here at the beginning, we are supposed to take the limit as h approaches 0. We're supposed to take this part right here, put x plus h into the original function. Squeeze right in here, squeeze in a tiny little x and x plus h. So we have, pardon me. So our function is supposed to be x squared plus 10, but instead we're going to have an x plus h squared plus 10, replacing the x with x plus h. What you see here in the blue brackets is the same thing that you see above in green. Same thing. Things in green are the same. Subtract from that the original function. The original function is just x squared plus 10. And this is all divided by h. To evaluate a limit, all you do is you take this 0 right here and you plug it in for each of these h's. If we did that right now, however, that would give us an undefined fraction because dividing by 0 has not and never will be defined. So I have to simplify this to get to the point where we don't have an h on the bottom. X plus h quantity squared, each time we have the limit as h approaches 0, is x squared plus 2hx plus h squared. Then I bring the plus 10 down. Once again, the green things here are identical. To get rid of these brackets here at the end, I'm going to distribute the subtract, so I get subtract x squared, subtract 10. The gray things you see up here are identical. This is all over h. So then this is equal to the limit as h approaches 0. In the previous step, things cancel. We have a plus x squared and a minus x squared, a plus 10 and a minus 10. That leaves us with 2hx plus h squared divided by h. At this point, we can factor an h out of the numerator. In doing so, we can cancel an h from the top and the bottom. We are multiplying the numerator by h and dividing it by h. H divided by h is 1. This leaves us with the limit as h approaches 0 of 2x plus h. It's really important that you have the parentheses around this. And I need a little bit more room here, so I'm going to take that room. At this point, we can evaluate the limit because we are no longer dividing by h. In essence, we were dividing by 0 this whole time. So now we can put 0 in for any of our h's and simplify it, and you get 2x. So in conclusion, the slope, the slope of the tangent lines is 2x. Just real quick, tell you what that means. I'm not going to do this for every problem, but let me do it for this one. The original function here was f of x equals x squared plus 10, which looks something like this. The vertex here at 0, 10. If you want to know what the slope is at any point on this graph, for example, this point right here, incidentally, that point is going to be the point 1, 11. Because you put 1 into this function, 1 squared is 1 plus 10 is 11. So what is the slope of the tangent line that goes through that point? Well, that's real easy to figure out. We just take this 1, we plug it in here for x. 2 times 1 is 2. This red line you see here must have a slope of 2. Notice this says the slope of all tangent lines is 2x. So all tangent lines have the potential being different. That's why there's a variable in this. Variable means varies, means things can be different. Let's say over here at this point, which is negative 214. It's negative 214 because if you put a negative 2 in to this function up here, negative 2 squared is 4, 4 plus 10 is 14. So what's the slope of that tangent line at that point? Take negative 2, put it into the slope. 2 times negative 2 is negative 4. This line has a slope of negative 4. One more. What about right here? What about this horizontal? Obviously a horizontal is going to have a slope of 0. But let's show it algebraically. If you put 0 in to the slope formula, 2 times 0 is 0. Slope is 0. This literally will give you the slope of any line that is tangent to this curve. That's what we're doing in this whole section. Number 2 starts out the same. Every problem starts out the same. Slope of tangent lines is the limit as h approaches 0 of the one and only difference quotient. Until you evaluate the limit, you must write the limit as h approaches 0. If we put x plus h into the original function, we're going to get x plus h quantity squared minus 25. I suggest, but do not require, that you put the f of x plus h in brackets to mentally separate it from f of x. F of x does need to be in some type of grouping symbol. I suggest brackets just to be consistent, but any grouping symbol will do. So we have f of x plus h here. We're subtracting from an f of x. Once again, this is identical to this, and this is identical to this. This is all divided by h. We would like to, right now, just put 0 in for our h's. At any point we can do that and get a defined answer, then we'll do it. We can't right now, because if we put 0 in for this h, we're dividing by 0, and that is undefined. So if we simplify our numerator, x plus h quantity squared is x squared plus 2hx plus h squared. Bring down the subtract 25. Distribute this subtract to the brackets. We get subtract x squared plus 25. This is all divided by h. At this point, in every problem, things should cancel. X squared minus 25 plus 25 cancels. What you have left, each term that you have left should have an h in it. If it doesn't, then with 100% certainty, you've made a mistake. At this point, we can factor an h out of the numerator. Giving us 2x plus h in the parentheses. Now we can cancel an h from the numerator and denominator. Canceling in this case means we're dividing the top and bottom by h, leaving us with 1s. 1 times 2x plus h, divided by 1, which gives us the limit as h approaches 0, 2x plus h. You need parentheses around this. If you don't, then it means find the limit of 2x when you're done, add h to it. So it's important that you have parentheses, so you're finding the limit of 2x plus h. We can now evaluate the limit. To do so, you simply substitute 0 in for h, and this gives us 2x. That is the slope of all tangent lines. That's it for number 2. Number 3, started out like you start out every one of these problems. Slope of all tangent lines is the limit as h approaches 0 of f of x plus h minus f of x over h. So what is f of x? Well, it's x squared, which we replace with x plus h, minus 8 times x, which we replace with x plus h, then plus 9. What you see in these blue brackets, that is f of x plus h. Subtract from that f of x. F of x is x squared minus 8x plus 9. At this point, we would love to take 0 and put it in for h. The numerator would work out lovely. The denominator would not, because we'd be dividing by 0, and that is undefined. We have to simplify this so that we're not dividing by 0. X plus h quantity squared is going to be x squared plus 2hx plus h squared. Distribute the subtract 8. We get subtract 8x, subtract 8h. Don't forget to bring down the plus 9. That's often where I make my mistake. Distribute this subtract to the second set of brackets, the black set. You get minus x squared plus 8x minus 9. Are there any like terms? Plus x squared and a minus x squared. Minus 8x and a plus 8x. A plus 9 and a minus 9. Once you cancel those things off, you should be left with only terms that have h's in them. If you're not, you definitely made a mistake, because every problem will cancel things that don't have h's in them. Every time. 90% of the time, it works every time. Now we can factor in an h out of the numerator. Every time I say numerator, I think of Tomb Raider, which I never actually owned because I never had a PlayStation. Put that in the book of things that you wish you never knew, but once you found out about it, you still wish you didn't know it. We can now cancel an h from the top and the bottom, and we have the limit as h approaches 0 of 2x plus h minus 8. Do you need these parentheses right here? Well, you don't need them unless you want to lose a point. So if you want to have all the points, you need it. If you don't care about losing a point, then you don't need it. Let me give myself a little more room. Now we can evaluate the limit. To do so, we simply replace all the h's with zeros. Gives us the slope of all tangent lines is 2x minus 8. Number 4, we have the function, which is a fraction. These kind of problems are very different. They all start out the same. That doesn't matter what the function is. They all start out the same. So we're supposed to take the function, replace any x's with x plus h. So that's going to be 1 over x plus h squared. Subtract from that the original function. Our original function is 1 over x squared. Notice I didn't use brackets here. I could, I don't need to. A fraction is a grouping symbol. So they have two completely different things here. So, how do we proceed? Well, when you have a fraction, it needs simplified. There's two things that are wrong with this fraction. One, the numerator needs simplified. And then two, this is a complex fraction. Two things that we don't like. Do not worry about the fact that it's a complex fraction until you first simplify the numerator. Then simplify the fact that it's a complex fraction. Simplify the numerator first, then simplify the complex fraction. Well, how do you do those things? Simplifying the numerator basically means getting rid of parentheses and combining like terms. And I'm going to contradict what I just said in a moment. I'll let you know when that happens. So how do I subtract these two fractions? I need common denominators to do that. This denominator is one thing, an x plus h quantity squared. Well, it's actually two things. It's an x plus h and another x plus h. This denominator is an x squared. They have nothing in common. Nothing. This, once again, if you factor it, is an x plus h times an x plus h. Those are the two things that make up that denominator. This denominator, x squared, consists of an x and an x. Also two things. Neither of those two things are the same. So they have nothing in common, which means that the fraction on the right needs to have an x plus h squared in the denominator. If you multiply it by the denominator, you have to also multiply it by the numerator. Once again, what does that mean? It means you're multiplying it by 1. Anything divided by itself is 1, so we're not changing the value of this fraction, we're just changing the way it looks. The first fraction needs an x squared multiplied times the top and the bottom. If it's more than one term, it needs to have parentheses around it. X squared is only one term. X plus h, quantity squared, also one term, but you need the x plus h in parentheses because inside it there's two terms. So what does that give us? It gives us an x squared over x squared times the sum of x and h squared minus x plus h squared over x squared times the sum of x and h squared. There's a couple different ways you can proceed with this. I don't care how you proceed as long as you do it correctly and you show all your work. I'm going to make this one fraction. That's what I'm going to do next. I have common denominators, so I'm going to make the numerator one fraction. So the numerator in my numerator is x squared minus the sum of x and h squared. The denominator in my numerator, do not simplify it. It is not wrong mathematically, nor is it wrong morally to simplify it, but it's a complete waste of time. It serves no purpose. So that's how I'm contradicting myself, because earlier I said simplify the numerator. That means to get rid of, to combine like terms and get rid of parentheses. But the parentheses you get rid of only need to be in the numerator of the numerator. If it's in the denominator of the numerator, you don't need to. So how does this simplify? We need to FOIL this out, and we need to be careful when we do it. Let me introduce you to the concept of side work. Side work is when you're manipulating a specific thing in a problem, but not manipulating other things, so you don't want to keep writing the problem down a billion times. Side work is called such because you do it off to the side. It's important that you know where the side work is coming from and also where it's going when you're finished. So let's simplify this. This is it's a subtract. We want to get rid of the subtract. We're getting rid of the subtract x plus h squared. We're going to simplify this. Well, this is equal to a minus x squared plus 2hx plus h squared. It's still in parentheses because there's a minus in front of it. When you distribute that minus, it's a minus x squared minus 2hx minus h squared. So let me change this arrow here. That is side work. For me, that's less work, but it's still mathematically showing all the steps because this was a two-step process, which means we'd have to write this fraction down an extra time. So I'm going to bring these terms over, a minus x squared minus 2hx minus h squared. Combine like terms. X squared minus x squareds cancel. So at this point, this is what we have left. The numerator is simplified. Now we worry about the fact that we have a complex fraction. So how do we fix that? Let me tighten this up a little bit. Here's what we do. So we have a negative 2hx minus h squared divided by x squared times the sum of x and h squared. Now we were dividing by h. We were dividing by h. Dividing by h is the same thing as multiplying by the reciprocal of h. We were dividing by it. Now we're going to multiply it by its reciprocal. So these two things you see in yellow are the same. Dividing by something is the same as multiplying by its reciprocal. I am running out of space fast. So how does that help? Well, right now it doesn't help at all, but it makes the problem look simpler. In our numerator of our first fraction, we can factor out an h. We can factor out more than that, but we only care about the h. H's cancel. Let me see if I can gain some more room here. So that gives us the limit as h approaches 0. I didn't gain much room, if you haven't figured that out, of negative 2h minus h over x squared times the sum of x and h squared. Let's evaluate the limit. We're going to put 0 in for our h's. There are still h's and h in our denominator, but that doesn't matter because we're not multiplying by it. I'm sorry. Should not have wrote down that. Once you evaluate the limit, you no longer write the limit as h approaches 0. So we have negative 2 times 0 minus 0. I made a mistake. I'm sorry, boys and girls. I factor an h out to the front. This h here should be an x. You've probably been screaming your head off at your monitor, or your iPhone, or your Droid. Sorry about that. Which then changes this. So it's a negative 2x minus 0. There we go. Over x squared times the sum of x and 0 squared. The numerator, we get negative 2x. The denominator, we get x squared plus x squared, which is negative 2x over x to the fourth, which is negative 2 over x cubed. So our final answer is the slope of the tangent lines equal -2 over x cubed. That is the slope of the tangent lines. Number 5. Slope of all tangent lines is the limit of the difference quotient as h approaches 0. So take the original function, replace the x's with an x plus h. When you substitute, you're supposed to use parentheses. I would encourage you to take the f of x plus h, put it in some type of grouping symbol, subtract from that the original function, which must be in some type of grouping symbol. Once again, we would love to evaluate the limit right now, but if we do, we're dividing by 0, which is undefined. So we need to simplify in hopes that we can cancel the h out of the bottom. Let's see what happens. X plus h, quantity squared, is x squared. You know what? I don't want to have to do this twice. So let's do a little bit of side work here again. Excuse me. When you do side work, note that you're doing side work. Call it side work. 6 times x plus h quantity squared equals 6 times x squared plus 2hx plus h squared, which in turn equals 6x squared plus 12hx plus 6h squared. And we're putting that right back into here. Subtract from that, distribute the subtract, and you get subtract x squared, subtract h. Pardon me. Subtract x, subtract h. And bring down the minus 29. Distribute this subtract. You get a subtract 6x squared plus x plus 29, all divided by h. Like terms, 6x squared minus 6x squared minus 29 plus 29 minus x plus x. So we have the limit as h approaches 0, h in the denominator. We got 12hx plus 6h squared minus h in our numerator. I see a potential problem here for some people. If you made a mistake on this problem, it is likely on this very next step. I bet the town cow on it. Yep, our town has one cow. Betsy. Factor an h out of the numerator, you're left with 12x plus 6h minus 1. If you made a mistake on this problem, it was likely there. When you're subtracting an h and you factor an h out of it, that means you're dividing it by h. You're left with a 1. h's cancel. So now we have the limit as h approaches 0 of 12x plus 6h minus 1. Running out of space, I'm going to go to the right and then back down here. To evaluate the limit, put 0 in for your h's. And that gives you 12x minus 1. The slope of the tangent lines is 12x minus 1. Number 6. Every problem starts out the same. Slope of all tangent lines is the limit of the difference quotient as h approaches 0. F of x plus h. We're putting x plus h in for this x and for this x. Notice there's a negative in front of it, and it's cubed. So we have a negative x plus h cubed plus 11 x plus h squared minus 2. That is f of x plus h. Subtract from that f of x, which is negative x cubed, plus 11x squared minus 2. Sorry about that. Going to do some side work here once again. I'm going to have to do a couple different side works. You don't have to do this side work, and you have to show the work. But I'm doing this off to the side, so I don't have to write all this down so many times. For example, this mess right here. I have a negative x plus h cubed. That is equal to a negative x plus h squared times an x plus h. When you're multiplying the same base, x plus h, add the exponents. This exponent's a 2, it's a 1. 2 plus 1 is 3. The reason I'm writing it this way is because I know that x plus h squared is x squared plus 2hx plus h squared times this x plus h equals negative . I'm going to multiply this x times each of these three terms. So that's going to be x cubed plus 2hx squared plus h squared x. Now I'm going to multiply the h times each of these three terms. You don't have to do the following. I'm just doing it because it makes things, for me, mentally a little bit easier. I'm going to line up my like terms underneath of each other. H times x squared is hx squared plus. And then h times 2hx is plus 2h squared x. And then h times h squared is h cubed. So this is equals negative x squared has no like term. 2hx squared plus hx squared is 3hx squared plus, these are like terms, 2 plus 1 is 3 plus h cubed. And now we have this pestering negative out in front, which is a negative x cubed minus 3hx squared minus 3h squared x minus h cubed. So I can replace what you see here in yellow with what you're going to see here in yellow, which is negative x cubed minus 3hx squared minus 3h squared x minus h cubed. Yellow things are the same. More side work. (11) times the sum of x and h squared. It's going to equal 11 times x squared plus 2hx plus h squared, which is 11x squared plus 22hx plus 11h squared. And that is going here next. Show where you start your side work, where it's coming from, and then where you're putting it back in. So these green things are going to be the same. Plus 11x squared plus 22hx plus 11h squared. Got a lot of problem left. And then I have this minus 3. When I make mistakes on these problems, it's usually that. Usually I forget that single term. And then we're subtracting from that. Distribute the subtract. And you're going to get plus x cubed minus 11x squared plus 2. Cancel like terms. Chuck, 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 chuck. This is a 3 and this is a 2. That doesn't sit well with me. It's supposed to be a 2. This looked like a 3 to me. It wasn't. It was supposed to be a 2. That's why it's good to know that at this point, everything that doesn't have an h in it should get crossed off. If it doesn't, you made a mistake. Since I know that, I know I made a mistake, and it was easy to fix instead of fixing it several steps from now. Equals the limit as h approaches 0. Oh, what is left? When I crossed this off, I didn't make it clear. It's that whole thing. Looks like I just cropped off the x squared. Negative 3hx squared minus 3h squared x minus h cubed plus 22hx plus 11h squared. Looks like everything else is crossed off. Now I can factor an h out of the numerator. I get negative 3x squared minus 3hx minus h squared plus 22x plus 11h divided by h. H is canceled because you're dividing the numerator and denominator by the same thing, h. Leaving us with the limit as h approaches 0 of negative 3x squared minus 3hx minus h squared plus 22x plus 11h. I do not like this h up here. It looks like something not an h. Equals. We can now evaluate the limit because we are no longer dividing by 0. Negative 3x squared minus 3 times 0 times x minus 0 squared plus 22x plus 11 times 0. That gives us a final answer of slope of tangent lines equals negative 3x squared plus 22x. These three terms all end up being 0. Number 7. Slope of all tangent lines is the limit as h approaches 0 of the difference quotient. So our x plus h replaces the x in the fraction. When you substitute, use parentheses every time. Parentheses is a grouping symbol. It's a type of grouping symbol. Here we have a fraction minus a fraction. The fractions are grouping symbols. You don't need brackets around them. If you want to put them around them, go for it. So we need to get common denominators to subtract these fractions. What do the denominators currently have in common? Nothing. When I say what do they have in common, I'm referring to factors. This is prime, x plus 2. X plus h plus 2 is also prime. They are not the same prime factor. Therefore, they have nothing in common. This fraction needs an x plus h plus 2 on the bottom. If you multiply it by the bottom, you got to also multiply it by the top. This fraction needs an x plus 2 on the top and the bottom. That gives us the limit as h approaches 0. This first fraction, the numerator is x plus 2. Denominator, do not multiply the denominator, even if it's in the numerator of the denominator. Even if it's in the denominator of the numerator. You can multiply it out, but it serves no purpose. It will not help you finish the problem. Therefore, it is a waste of your time. Your time is valuable. Do not forget that this is subtract. So it's x plus 2, subtract x, subtract a plus h, subtract a plus 2. So when you put this in one fraction, you can do it in a couple of ways. I need a little more space. X plus 2 minus. We're subtracting each of these. So in essence, we're distributing the subtract. These are 2's. What looks like z's are 2's. Pardon my penmanship. What cancels? X and an x, a plus 2 and a minus 2. So what's left? The negative h is all that's left in the numerator of our numerator. At this point, since the numerator of our numerator, I hate saying that, it sounds really confusing, since it is simplified, stop dividing by h. Dividing by h is equivalent to multiplying by the reciprocal of h. Reciprocal of h is 1 over h. Cancel an h from the top and the bottom. It leaves the numerator a negative 1. So we have the limit as h approaches 0 of negative 1 over the sum of x and 2 and the sum of x and h and 2. Now evaluate the limit. Evaluating it means to replace the h's with 0. Running out of space, so I'm going to go to the right here. We get x plus 2 times sum of x and 2. Multiplying something by itself, a shorthand for that is to write the thing that you're multiplying by itself, and however many times you're multiplying it, you put that as an exponent. So the slope of all the tangent lines to the original curve is -1 over x plus 2 quantity squared. Number 8. We're going to have the limit as h approaches 0 of 1 over x plus h quantity squared minus 7 minus 1 over x squared minus 7, all divided by h. This denominator needs multiplied by an x plus h squared minus 7. Do it to the top and the bottom. This denominator needs an x squared minus 7 multiplied times the numerator and denominator. You must have it in parentheses. If you don't, it's wrong. It's that simple. That gives us the limit as h approaches 0 of x squared minus 7 over x squared minus 7 times x plus h quantity squared minus 7. I'm having brackets here because I have parentheses inside of it. Subtract from that x plus h squared minus 7 over the same denominator that we just got. Sum of x and h squared minus 7. This is all over h. Can now write this as one fraction x squared minus 7 minus this mess here that needs multiplied out. This could have been multiplied out, this referring to what you see here in yellow, at any point in this problem. You may prefer to have done it before now. You may prefer to never do it. You have to do it at some point. So let's multiply what you see up there in yellow out. Let me write everything else down. So once I multiply it out, I can just write it down, have everything else waiting for me. So x plus h quantity squared. Let's do this off to the side. Including the negative in that. X plus h quantity squared is x squared plus 2hx plus h squared. Minus 7 at the end of it. Distributing the negative, you get negative x squared minus 2hx minus h squared plus 7. So that yellow mess becomes this yellow mess. Don't like this h so close to me. Things cancel. Things must always cancel. Minus x squared and a plus x squared, and minus 7 and a plus 7. So what is left? I should say where this went. This went right into here. And the yellows are the same. So we have the limit as h approaches 0, negative 2hx minus h squared divided by x squared minus 7 times the hot mess that you see here. Instead of dividing by h, we're now going to multiply by its reciprocal. Dividing by h is the same as multiplying by the reciprocal of it. You can factor an h out of the numerator. You can cancel that h then from the top and the bottom. Canceling meaning divide the top and bottom by that number. So what's left? This is what's left. You can now evaluate the limit. That means replacing all the h's with 0, because it says h is approaching 0. And I am running out of space yet again. So we have in our numerator negative 2x, in our denominator an x squared minus 7 and an x squared minus 7. It gives us negative 2x over x squared minus 7 squared. This is the slope of all the tangent lines. Can't lose track of what we're doing. We're finding the slope of the tangent.